Hey everyone, Nick Russo here. I've encountered another reason to improve my website as code project. I don't want to reiterate the same architecture overview 3 times, so please watch the first 2 videos before continuing. I've included them in the description below. Our main goal today is to leverage AWS S3 to build a URL shortener. Long story short, I've been using tinyURL for a while, but they recently inserted a middleman into the redirection chain rather than directly referencing my URL. They likely did this for affiliation reasons, and frankly, this adds 0 value to me or to my customers. It makes pages slower to load, wastes bandwidth, and lines the pockets of some random internet company. Fortunately, AWS has a simple solution. Let's zoom in on an example redirection request using my new method. Suppose you see a tweet from me advertising some new YouTube content and you click on the URL shown. Each one of these redirection targets is a file within S3 that has some special metadata associated with it. That special metadata allows AWS to treat the object not like a standard file, but like an HTTP redirection trigger. In other words, the file's contents are irrelevant and only the metadata is processed. In HTTP, redirection is signaled using a combination of a 300 series return code and the presence of the location response header. This contains the next URL in the chain, and in my case, it's the final destination. The client unpacks the HTTP response, acknowledges the redirection, then issues another GET request to the location URL. This ultimately results in successfully browsing to the destination resource, which in this case is a YouTube video. I'll show you how these files work in just a minute. Before we dive in, the CI/CD pipeline requires 2 updates. First, we need to upload these redirection files using a special technique. We can't just bulk copy them because each one has special metadata. We'll use a bash script, along with the AWS CLI tooling, to individually upload each file. Next, we'll extend our post-build testing. In part 2 of this series, we added some cache test file checking using a standalone Python script. We'll repeat that process today using another Python script to validate that the redirection file metadata was assigned correctly by the bash uploader. I've listed the contents at the top level of my website directory. You'll notice a new R directory, short for redirect. Let's peek inside. Each one of these files is plain text and contains the full URL that is used for redirection. Let's pick one at random, perhaps the PS IPv6 file. This references my most recent Pluralsight course covering enterprise IPv6 transition technologies. The file contains the actual URL where the resource lives. Thanks to this redirect file, we can access it using njr/usmc.net/r/ps IPv6. That's easier to remember, type, and post on social media. All these other files are similar, they just have different URLs. Next, we need to upload these files to AWS S3 while somehow specifying that the contents of the file should be assigned as the redirect URL. I solved this problem using bash. The copy_redirects.sh script handles that for us. Let's review it next. The file is very short and only contains 6 executable lines. First, let's find all the files in the R directory, ignoring the directory itself by matching only regular files. For each file, we'll print a status message revealing the file name. Then, we'll read the contents of the file into a variable named redirect URL. I found this to be the most elegant approach. It's simpler than maintaining a large YAML or JSON file mapping file names to their redirection URLs. Let's print the redirect URL just for confirmation, which is useful when reviewing CI/CD logging. The final and most operative step is to perform the upload. We copy the specified file into the remote R directory within the S3 bucket while also setting the website redirect option to the redirect URL. Behind the scenes, this assigns the x-amz-website-redirect-location metadata field on the object. This allows S3 to set the location response header to the same value in response to a GET request. This process occurs individually for each file, and the loop continues until all files have been uploaded. Next, let's check the buildspec.yaml file. This reveals the sequential steps taken to process a build. Since the last video, I haven't made changes to the install or pre-build phases, so we'll skip those. The build phase has 3 updates. First, I spread the AWS S3 copy command across several lines for readability. I used the well-known Yaml folded mode operator, which is the greater than sign, to collapse all these command options into a single command string. Next, we must exclude the R directory from being bulk copied. Instead, we'll call our bash uploader at the end of the build phase, which is the 3rd update. That will handle the redirection files and their corresponding metadata. Like all good coding projects, we should validate our work. I've created the check redirects.py script to run after the build completes. Let's explore how it works. The script imports 3 common libraries. OS is used for interacting with the file system, sys is used to exit the program with a custom return code, and requests is our HTTP client. In the main function, we receive a parameter named directory, which, as we'll see later, is a string set to r/. You could apply this as a command line argument for flexibility, but that's unnecessary in my case. After initializing the failure count to 0 and defining an HTTP session object, we loop over all the files in the R directory. This is similar to what the bash script did, at least initially. Next, we'll define the file path by appending the file name to the directory, then attempt to read the contents of the file. This should give us the redirect URL. Now that we have it, we'll print a status message for logging purposes, then issue a head request to the shortened URL. Remember, this shortened URL is something like njr/usmc.net/r/ps/IPv6, and we expect that the location response header is equal to the redirect URL contained in the file itself. That string would contain the actual URL, somewhere within pluralsight.com in this example. Although the head function automatically sets allow redirects to false, I like to set it explicitly. This protects me against behavioral changes in the future and also makes the code's intent more self-evident. Next, we'll perform some checks. We want to ensure the response was a redirect, meaning it has a status code between 300 and 399 inclusive. If so, let's extract the location header and compare it to the redirect URL. They should exactly match. If they do, the test succeeds and we loop again. If they don't, there was a URL mismatch, so let's reveal both the location and redirect URL variable values for troubleshooting purposes. If the response wasn't a redirect at all, let's print the status code that was returned. That will help us troubleshoot the misconfiguration at a higher level. When the loop completes, we'll exit the program using a return code equal to the number of failures observed. 0 means success, and anything greater than 1 will cause the CI testing to fail. Last, notice that r/ is passed into main, and again, you could customize this for your environment. Let's head to the AWS console so we can see the final result. To save time, I've recently performed a git push to trigger a build, and we'll review the results. Within S3, I've navigated to my website bucket and into the R directory. We can scroll down to see all of the redirect files. To be consistent with the earlier parts of the demo, I'll click on PS IPv6 so we can explore the file details. The file's metadata is towards the bottom, so I'll scroll down. Since we no longer care about the file contents, the content type is irrelevant, even if it is technically incorrect. Of greater importance is the x-amz-website-redirect-location attribute, which references the proper Pluralsight URL. Thanks to our Python script, we don't have to manually verify every file, but this is a good way to confirm success during initial development. Next, let's head over to the code build service. I've pulled up the most recent build, which succeeded and took about 3 minutes to run. Let's review the logs. I'm skipping all the content covered in the first 2 videos and focusing primarily on the new stuff. First, our bash script runs, reading the contents from each file and individually uploading them. Each one is about 1 kilobyte on average, so this process is very fast. Let's check the validation logs next. Scrolling down a few hundred lines, the CI system runs the check redirects.py script next. Each shortened URL is individually validated by comparing the location header from the HTTP response with the file's contents containing the redirect URL. Since the overall build passed, we can be confident the URL shortener is working. The final phase of testing is user acceptance. Let's open a new browser window to manually navigate to the shortened URL. I'll use Safari instead of Firefox because I'm not logged into my Pluralsight account over there. From here, I'll manually type in the njrusmc.net/r/ps/IPv6 URL and hit enter. Okay, that looks great. The redirection clearly worked, as evidenced by the updated URL box and Pluralsight course title. Thanks for sticking with me through the video, and I hope you found it as interesting as I have. Until next time, take care.